Doesn't look like it's streaming. Oh, maybe am I not sharing my video? Is that what it is? Oh, maybe that's what it is. Right, can you all see me?
Yep.
Let me share my screen, see if that's. Oh. That's what it was. All right. Let me bring up the chat, leave that to one side. Anybody watch the Mars rover landing? We're big fans of space here in this house. My son is studying to be a aerospace engineer. He's going to be graduating later this year in May. So we're all excited about anything had to do with space. Like I wear my SpaceX hat at some point. I'm lagging. All right, let's give it a minute. I think it'll improve. Let's see. Covered intro, update, group by. Zero Jr. Is your son studying at Northeastern? No, he's at Purdue. That's where Neil Armstrong went to school. So that's one of the reasons he went there. All right, excellent. Welcome. Let's see. All right, so let's real quick. We're finishing up the 5th week, where the first week we installed the relational database, and we played around with creating a simple table, inserting, deleting, updating, retrieving data. We then designed the database using UML class diagrams. Then we spent a week on how to create the table, the relational model from the conceptual model. Then last week we spent some time how to retrieve data from a database that we were giving you. And this week we're spending some time practicing how to populate and update a database that already exists, right? So we covered earlier this week, we talked about SQL insert, and we saw that there was a couple of different versions of that syntax, right? Being able to just insert and follow the same structure of the table, where you have the columns that you want to insert, and then the values, or just only the values, and then it figures out which columns are you referring to by the order in which you provide those values based on the original create statement. And we saw that we can also do copy data from multiple tables, right? Do a select statement that identifies certain records from other tables, and then we can insert those into a target table. We then spent some time doing looking at update and delete. We looked at those on how to modify records that were already in the database and how to remove them as well. We then revisited group by, which and we saw that there were some limitations on group by. Depend if you look at the way that the records are identified, they're going to be grouped. It's right after the where clause, right? You first run the where clause, identify the records, the subset of the records that you're talking about. Then they're grouped right together, and then you can aggregate those values and then refer to them in the select statement. So we'll look at some of the limitations, how to get around those limitations. All right, so having done that, let's move on. A couple other things that we want to cover that we're a little bit advanced, but I think we've gathered enough self-confidence that we can spend some time here. So let's talk about modeling class inheritance, right? And this is going to start talking into one of the challenges when working with relational databases, and that is that the technology is moving forward, but relational databases were invented way back when many ideas in programming had not yet appeared. For instance, relational databases were invented before object orientation, right? And many of the modern ways that we think about developing software, right, have moved on from when these databases were invented. So there are many things that are not supported natively in relational databases that we take for granted in programming languages, right? Like inheritance and object orientation and so but we still need to be able to convert these conceptual ideas into something concrete in a relational model, right? So one of these ideas that are conceptually very common in today's parlance, right? Whenever you're talking about any programming language like object orientation and inheritance, those don't have an equivalent in relational databases. But we still have to implement them, right? Even if somebody designs something like this and comes up with a UML diagram that has a base class and several subclasses, even though there's no equivalent in relational databases, we still need to see how is it that we can convert this diagram into something concrete. Okay. So there are many different object-oriented design concepts that have no equivalence. Even so, we need to somehow simulate that behavior. Okay. So let's first look at conceptually what this means, right? If you have a base class, right, that defines several attributes such as title, points, description, instructions, right? So this might be a UML diagram that is describing the relationship amongst a very generic question and then specific types of questions, right? Where you have essays and fill in the blanks and true and false questions. So you have many different types of questions, and they all share certain things that are common to themselves, right? So for instance, they all might have a title, right, for the essay. They all might have the actual question, right? They might all have how many points is that question worth, right, in a quiz. And so the way you would implement it is that each one would have its own attributes, just repeatedly described in each one of these classes. Yes. Well, what object orientation introduces is the idea that you can grab all the things that are common to all those classes, and instead of repeatedly describing them over and over in each one of these classes, you can create a super class, right, where you can grab everything that is common to all of them and just move them up, right? Move them up into a common class that they can all inherit from. Okay, they can all inherit all these attributes, title, points, description, instructions, that are common to all of these, right? Why not declare it at a higher level, right, and describe a more generic a question, and then each these would be specific types of questions that would inherit all those fields. So this essay inherits these 4 attributes. Fill in the blanks inherits those 4 attributes, plus they add certain attributes that are specific to the fill in the blanks. Same thing with true, false, right? Inherits these 4 attributes and then adds specific attributes that are for that class. Okay, so that's in a nutshell object-oriented inheritance. Well, there is no equivalence of that in relational databases. Nevertheless, there are techniques that we can follow, right, to simulate, right, this behavior. Okay, so there's 3 different strategies that might work. Okay, so we're going to look at all three, and they all have their pros and cons. Okay, so let's take a look at all three. Right, one of them is called the joined or normalized. The other one is single table, or also called denormalized, and table per class, which is kind of like a hybrid of the two. All right, so let's take a look at the first one, joined, or also known as normalized. Okay, so in the joined strategy, what we do is that we take the base class or the superclass, and we create a table just like you would any other class. You would convert it into a table, right? And this is pretty straightforward, right? We have these attributes, right? That you have title and point and description, and you would just declare those attributes over here, right? You have the description, the instructions, the points, and their appropriate data type, right? Plus, you might add also a primary key as well. And so nothing new here, no, nothing earth-shattering. Okay, so let's now revisit the fact that we want to create now this relationship between a base class question, right, and then a subclass true false. Okay, so how would you go about it? Well, one of the straightforward things to do, right, is to create this other class true false. So for instance, you might create a true false table. There it is. And you would declare a field for that attribute right there, right? Is true. So you would create the is true, right? And probably also a primary key. And that's about it, right? So you would go as far as that, right? But how is it that we would establish the fact that there was a relationship between these two, right? So just conceptually, if we go back to the object-oriented idea here, is that when you instantiate, in Java or C#, when you create an instance of true false here, right? You would inherit not only this attribute. I mean, not only would you have access to this one attribute, which is you declare in that local class, but you would also have access to all these other values as well. Right? So how would you store that in memory? To put it in a database. Well, it would be that the strategy could be that some of the attributes, right, would be stored in the question table, and some of the attributes would be stored in this new true false table. Yes. But then when you want to recreate the question true false, you would have to merge together some of the attributes that are stored in the question table and with some of the attributes stored in the true false table to get the entire data, right? So you would have to somehow join these two tables, right? Fetch the fields that you are inheriting, and you would have to merge it. You would have to join it, right, with the field that you are specific to you. Okay, and so to be able to do the merging or the joining, right, we need to create a foreign key relationship to our parent. Okay, so this is a primary key for the base class. Okay, and this one would have a foreign key to the base class as well, right? Which would mean that I could now join the foreign key of the true false with the primary key of the question, and then I can recreate the original record that contains data from the question for my parent and the data for my local version here. That makes sense? Okay. One other thing, notice that is that this ID, this primary key, notice that what we're using as a foreign key to point to our question is also our primary key, right? So our foreign key is also our primary key. See that? That means that there is a one-to-one relationship here. Yes? So this primary key in the question is the same as the primary key here in the true false here. Okay, and it's also a foreign key that is relating to the parent key over here. Make sense? That means that there's a one-to-one relationship, which makes sense, right? Because when you make an instance in memory in Java or C# of the true false object in memory, well, that instance has data for both, right? It's a special attributes for true, false, plus it has data for the ones that it inherits. It's one single instance, right? You could not, for instance, have a class, an instance of true value without the instance variables that you inherit from question, right? So they really should be treated as one and the same, right? One cannot exist with the other, and that's why we have this foreign key being the primary key is also the foreign key to the base question. That makes sense? Okay. So similarly, we can do the same thing with fill in the blanks. Fill in the blanks is declaring some of its fields that are specific to that class, which is variables, which is a string, right? And it's inheriting these attributes from the base class question. Okay, so same thing, right? We have our own primary key. There it is, and we are declaring our own specific value or attribute that is specific to this class. And then we are using our primary key to be a foreign key that references the base table. That makes sense, right? All right. So what does this look like in a database once you start inserting actual questions in a database, right? So imagine we wanted to create one joined. So here's a one joined question. One okay, where is true. It might be a tiny int, right, which is true, right? And then you have whereas in the fill in the blank question, we have for the column we have variables, right? So these are the value, the specific value for that record. And notice that for primary key here, this one is also a foreign key that is relating to some other record, right, in the base table, right, the joint base question, which is this right here. See 2 and 3. 2 and 3 describes the values. This one right here, right, the instruction and the description and how many points, right, and what the title is for fill in the blank question here, number 2. See that? And same thing, this one right here, number 3, right, has the descriptions and instructions and the points and the title for question ID 3, which is for the true false question ID number 3. See that? Okay. So again, some of the data is stored in one table and some of the data is stored in this other table. Okay. And so with this strategy is referred to as the denormalized strategy, right? Because in a denormalized strategy, we break up the data into separate tables, right? And this is what we're doing, right? We're breaking up the data that is specific to the fill in blanks in one table and the data about question in another table. And then you have to join the two tables to reconstruct the original data that we broke up. Make sense? So it's referred to as the denormalized. The normalized strategy. Now, there are some pros and cons. Okay, so I guess we can put here. We should put here pros and cons. Okay, so pros is that it's fairly intuitive. Right, so it's fairly intuitive. Okay, there's no redundancy. No redundancy, so there is no inconsistency. Okay. Now some of the cons, right, is that it's slow. Okay. It could be very slow. All right. Imagine, right, going back to this class diagram, that if it's just this subclass that is inheriting from a superclass, well, that's fine. You're joining two tables, right? But imagine, right, it's not uncommon in when you're doing object-oriented design and development, OOD, that you have fairly long inheritance chains, right? Where you have a superclass A, and then B inherits from A, and then C inherits from B, and then D inherits from C, right? And so you have these long inheritance chains, right? Where you have a superclass, subclass, 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 subclass. Now imagine trying to convert that into a database, right? That would mean that you would have to create tables for each one of those classes, and each one having foreign keys to their parent a superclass, right? And if you want to create an instance of B, for instance, you have to join A and B, right? But what if you want to create an instance of C? Well, you're going to have to join A, B, and C. So it's a three-way join, right? So remember, every time you do a join, you are increasing the complexity of having to match multiple records from multiple places, right? Remember that if you don't have any join and you're looking for records in a table, then the complexity is order n, right? Meaning you have to iterate over the table looking for those records, and the bigger the table, the longer the time will take you to retrieve things, right? Well, if you consider two tables, then it's not order n anymore, it's n squared, right? Because you have remember you have a cross product that is looking at all the possible combinations, right? And you have a squaring effect there. You have an outer loop and you have an inner loop that iterate over both tables. Well, if you had a third table, now it's order n cubed, or four tables is order n to the 4, right? So every time you add a new table, it gets very, very slow. You're doing all those cross products and doing all those looping between tables, looking for your data. Let's see something on the chat. How do you prevent multiple subclasses? Oh no, you don't prevent that, right? It's what you want, right? So here you want the what do you mean? I'm sorry. How do you prevent multiple subclasses references the same question ID? The same question ID. Oh, you mean that where you might have two questions referencing the same like, for instance, this might be 3 and this might be 3. Is that what you're saying? Like an instance, Well, one of the things that we'll learn about this is that all these mechanisms are not implemented by hand, right? It's not like you would create these tables and you would do the inserts and the retrieval, right? Instead, you would rely on mechanisms that would automate this for you, that would do for you the storage of this data and the retrieval of this data, right? And as we'll see next week, these tools are called ORMs, or object relational mapping, right? These are tools that map something that is object oriented, right, such as this, and map it to a relational model. So it's an object relational mapping, right, software, and the software would do this for you. It would create the tables for you, right? All these tables would be automatically generated from a diagram such as this, right? And all the inserts and all the updates and the retrieval, right, would not be done by hand. So yes, you could inadvertently have two records pointing to the same parent, right, which would be a mistake, right? And so the software would not allow you to do that. Yep. Yeah. So even though this is very intuitive and it's easy to understand, and definitely you have no redundancy, it could get slow, right? Slow for long inheritance chains. Okay. So to deal with this problem, we have in the other extreme, no redundancy. So this is normalized. It's normalized. In the other extreme, we have the single table approach, right? So in this strategy, we kind of have like the opposite of what we just looked at, right? Instead of having multiple tables, right, one per class, what we do is that we merge all of it. We flatten the tree, right? So if you have a long inheritance tree, right, where you have the base class, a subclass, a subclass, a subclass, and so on and so forth, what we do is that we flatten that tree, right? We squish it and then make one single, as if we had a one big, huge class, right? Basically, we are going the other way around. We denormalize, right? Instead of normalization, right, where we break up all the data into multiple tables, right? We go the other way around and we denormalize. Right? Remember, we said, hey, don't have everything in one single huge spreadsheet, right? Or one big table, right? Because you're going to have a lot of redundancy and you can have a lot of inconsistency. Instead, break it up into smaller different tables, right? Then we call that normalization, right? Because we want to avoid, we didn't want to break first normal form, second normal form, third normal form, right? We want to make sure that we normalize. Yes, we're going here the other way around. We're telling you to denormalize, right? And obviously this would entail getting into the risk of redundancy, risk of inconsistency. Well, definitely redundancy, right? But you would also definitely get, because you have redundancy, you're entering into a risk of inconsistency, right? So everything we've told you not to do, here we're saying that this could be actually a valid strategy. Okay, so here what we've done is that we've taken this all these 4 or 3 or how many classes, made it one single huge class, right? That's going to have all the attributes, right? Not only the ones here in the base class, but we're going to bring in all the ones from the fill in the blanks. We'll bring them over. The true false, we're going to bring them over, all of them, and put them in a single table. And there it is, right? Notice that these are the ones from the base class. Plus, now we're added the attributes from our subclasses into one single table. Make sense? Okay. So basically, we're doing what we've been telling you not to do. Okay, which is if you're going to do this by hand, right, and you're going to be writing your own source code, then this would be discouraged, right, to do something like this, right, because this is very error prone. You're going to end up with a lot of redundancy. So oftentimes what we do is that we don't do it ourselves. Instead, as I mentioned earlier, we use software that does this for us, right? That can manage this redundancy, right, without the possibility of inconsistency, right? We're going to introduce later on next week ORM, object relational mapping, which is going to allow us to do this for us, right? It's going to create these tables for us. We need to tell it just what strategy do we want, right? The single base strategy, the single table strategy, the denormalized strategy, the normalized strategy. What is it that we want, right? It'll create this all for us, right? But nevertheless, here is us doing it by hand, right? We create our table, and notice that we have the fields from our base class and then our fields from our subclasses all in one single table. Plus, we're adding an additional field over here. Okay, so this field is an added field that was not in there, did not exist in any other table. Okay, and it's going to allow us to distinguish, right? Now that we, before we had, we had the tables themselves as a means of knowing what instance of this is, right? Is it a true false question? Is it a fill in the blank question? Because it lived in a particular table, it was obvious, right? We knew what it was. But now, because they live in a single table, we've lost the capability of distinguishing, right? What type was this? What record was this? What instance was it? Which was it? So we're going to use a D type, right? That D for discrimination. Discrimination not in the bad sense. Discrimination as in being able to distinguish, right, one from the other. Okay, so D type, it's a field called a discriminator field that allows us to store in there and say, oh, this record was of a fill in the blanks question. So we put in here saying, oh, it's a fill in the blank. Or if it was a true false question, here we also just record that this was a true false question. Okay. Now, what this allows us to do is that it allows us in our logic, in our source code, allows us to determine, hey, if this is a true false question, then I should have a value for is true, either true or false. And probably I will have nothing for this field for variables. They'll be null, right? In that one record. Instead, if the type here was that it was a fill in the blank question, then the inverse, the opposite is true, right? We will probably have a value for this field, but for this value, it will be left null. Okay, it's actually very common that if this would have been a large, a long a set of classes that are inheriting from each other, right? A long hierarchy of inheriting classes, you would end up with lots of fields here that are specific to one class or specific to another class. Okay, and if it's a particular type, then a lot of the other fields are going to be null, right? And so you're only going to have values in that one record. You're going to have values only for a subset of those fields. Everything else would be null, right? And this is sometimes frowned upon by system administrators, right? That they don't like to see, large sparse databases, right, where you have lots of nulls everywhere, right? They hate that. But nevertheless, there's a very common technique. It improves performance tremendously because you don't have to merge things, right? You don't have to do the joining. Now, if you only have just a few, maybe just a two layer inheritance, right? One base class and then just one subclass, then it makes sense to perhaps go with this strategy. Go with this strategy, multi-table. If instead you see that you have a very, very deep inheritance chain, then definitely this is a better performer. Okay. Yeah. So for instance, here's an example that you can retrieve data for some of these tables. And for instance, here there's a fill in the blank table. Notice the D type is telling you what the original type was, right? Fill in the blank. And notice that we have value for fill in the blanks, but it's null for the is true. Whereas for the true false, we have value for that, but not for the variable. Okay, that makes sense? Right, so in practice, right, in industry, this is the more common technique that engineers use, right, to implement inheritance. Right, this is by far the most common technique. Now, there's another technique which is kind of marries both strategies, right? It borrows from both strategies in that it tries to do like a marriage, the best of both worlds. Try to have best of both worlds, right? Where what we're going to do is that we're still going to be denormalized. I mean, we'll be normalized, meaning we're going to have one table per class, right? Very much like we did before here, right? We're going to create one table for the base class, one table for the subclasses, and each one table each for the classes. So same thing, right? We're going to do the same thing. We're going to have a base class, right? And then tables for the subclasses, right? The difference is that instead of squishing like we did here, right, that we squish all the fields, right, of the subclasses, we squish them up into one single class, we're going to go the other way around. We're going to copy the fields from the top level class. We're going to copy them down, right, into the subclasses, right? So instead of copying all the fields up to the top class, right, and then having one big table that has all of them, we're going to go the opposite, right? We're going to start off with the base class, right, that has only the fields that are common to all classes, and then when we create all the other classes, like the true false, what we're going to do is that we're going to copy down, right, all the fields from our base class, our base table. We're going to copy them down to our specialized class. See that? So this one is almost kind of doing what the name says, right? We're inheriting, right? we are inheriting all these fields, all these columns from our parent, right? And so rightfully so, we copy down all the fields from our parent, which are these over here. All right, so let's paint this say yellow. Well, no, actually no, bluish. Okay, and so here, there they are, right? We copy them down. So these bluish, oops, what happened? Bluish right here, or is the same as these bluish over here, right? Right, so notice that we're copying them down. So now I have the same fields that my parent has, right? So that the data, when we insert the data, it would be inserted into this bottommost record, okay? So that if I need to retrieve the record, there's no need for me to join myself with my parent. See that? Right? So it has the kind of like the best of both worlds. It has the performance of the single table, but it also has the denormalization of the joined strategy, right? It kind of has best of both worlds. Same thing here in the fill in the blanks, right? I've kind of inherited those fields literally into my table down here. Make sense? All right, excellent. So those are the strategies. And so in an upcoming assignment, you'll be asked to implement something like this, right? We'll give you a base class, right? And we'll give you a couple of subclasses, and we'll ask you to use one of the strategies, right? The normalized strategy for one inheritance, and we'll ask you to use a denormalized strategy for the other inheritance. Okay, and you'll go ahead and you'll implement it yourself. Now you'll do this by hand right before we tell you to use the ORM, right? Because the ORM will take care of this automatically for you. But it's a good thing for you to practice it on your own before understanding, what's really happening behind the scenes in these ORMs. Okay? Any questions? All right. Okay. Let's continue. I did want to go over real quick the previous quiz number 2. In particular, I wanted to just talk about a little bit about the types of questions that you're getting and what is being expected, right? The type of answers that we're expecting. Now, obviously, what we're trying to do is as much as possible make the quizzes available to you so that you can work on these on your own asynchronously, so that you can have 48 hours and based on your zip code or where you are in the world, you can work on this on your own. So we're trying to automate this as much as possible so that to make it easier on everybody. So a couple of things that we're going to expect are some assumptions. Is that to make this easier to grade automatically, right? We're asking you not to use periods or commas or semicolons or any special characters, unless it's absolutely necessary. Obviously, right? If unless the question that I make makes no sense, if you don't have any of these punctuations, then by all means use it, right? And if for some reason you lose points, just call me out and then we'll give you the points back, right? But we're trying to write the questions in such a way that you don't need any punctuation. Also, that ideally you won't need either to put quotations, single quotes or double quotes or backticks or anything like that. All right. So because obviously because you might be taking this in different time zones and we're not there to answer questions for you. Some of the questions would be, should I answer with or without quotes? Should I put a comma or not a comma? So we're trying to make it as simple as possible that you don't need any of that. Okay. So when in doubt, leave out the commas, leave out the quotes, leave out anything. Okay. Also, no white spaces. So, don't add any extra spaces or any tabs or any new lines. Just the text, right? Don't put any spaces before, no spaces afterwards, right? Again, for automating this, the grading. Now, there might be that we might have made a mistake. There might be some syntax error in the question, or there might be something missing. We're not trying to trick you. We're not. It's not like we want to. We want you to. We're gonna try to put some trick question where, oh, you forgot. No, you didn't realize that I missed the comma or semicolon or whatever. No, we're not trying to trick you. Okay. When we're asking you to see where the syntax is, it'll be very clear that we're asking you to see if you know what the syntax is. All right. Also, the fill in the blanks. Now, some of the questions, what we're trying to do is that each one of the fill in the blanks, the easiest thing for us would be that you answer a one word for each blank that you have to fill in, right? Now the question comes in when there are some words that are compound words, okay? And so we're asking you to split those compound words into individual fields, all right? Also, to use all lowercase. I believe the questions that we made are all case insensitive, but it's easier if we standardize it to be all lowercase. So here's the questions that you might have gotten. And so in this one, we were asking you to create a table, and you might have had to fill in the blanks. And so this was an integer, string, date, boolean. I still owe you the fact that this could be date or date time, right? So we're still grading that, and if we put date time, we're gonna regrade that and we'll give you the grade back. Also for tiny int, if you use boolean, we'll also give you the grade for boolean. So boolean would have been okay as well. This one was about one to many, and again, it was fill in the blanks. We said many instances of B are related to an instance of A. So I think there was an error in this question, right? Which it's backwards, right? This says and many instances of B. So for this to be many instances of B related to one instance of A, right? The only way to do that is that oh, wait a minute. Many instances of B. B has. Oh no, okay, that's correct. Many instances of B has foreign key to related to one instance of A. Yeah, that's correct. Yeah, foreign key. No, that is correct. Maybe was there another one that was miswritten? Many instances of X with a foreign key to Z. Yeah, no, that's correct. R, many instances of R to many instances of many instances. Oh, okay. I think this was the wrong one, right? Yeah, this is supposed to be R, and this is supposed to be T. Yeah, so this one has an error, so we're gonna fix this and give you points for this back. Many to many, right? We created two tables, table A and B, and each one had its own primary key, and we were asking you to create a table that would map between A and B, right? So here's table C that has two foreign keys, one pointing to A, the primary key in A, and the other one pointing to the primary key in B, right? So this is a classical mapping table, right, that created records that reference two tables, right? A classical many-to-many implementation, right? Also, we had different versions of these questions that would randomly pop up. So you might have gotten this question, the ABC question. Some other folks might have gotten the QWE question, but it's the same exact question, right? The only difference is that it uses different names for the tables. Okay, we're trying to randomize these questions, right, to kind of discourage folks from copying from each other. and to encourage you to, obviously work on your own. These are all obviously supposed to work on your own. So ASD, same thing. These are identical to each other, except that we are changing the names of the tables, and sometimes the values are different, right? But the complexity is the same no matter what question you get. Self-reference. This was what where you would have a table having a primary key that was also a foreign key that was referencing itself, right? So this was foreign key B referencing itself. This was same thing with X, same thing with R, right? And you might have gotten different questions there, but it was just self-reference. Okay.
Professor?
Yes.
So I got a version of the question which I had to use X, but the grader said I got it wrong because I didn't put R there. And if you look at it, it's like the same position where you place the X and the R. So I think for some reason maybe the grader got confused, and then it was like looking at the different questions or a different version of the same question.
Yeah. We're working through this, and we did get a couple of these syntactically wrong, and so we're manually going through this and giving you the points back. Yeah. Hopefully in quiz number 3, we did a better job, and we're not going to get these errors. But let me know, right, if you do. Okay. All right. Let's see. Let's keep going. All right. Let's see. Updating inheritance. Okay. Let's talk about top, limit, and pagination. All right. So oftentimes when you are working with large amounts of data, you typically only want to work with a subset, right? It is usually databases is not uncommon that a database will have thousands, tens of thousands, millions of records, and obviously you can aggregate them, right? You can condense that data into and do a calculation that will give you something that summarizes that huge amounts of data. Yes. But oftentimes you just want to be able to navigate through it, through this, right? And just for instance, you might have a long list of movies from Netflix or whatever, right? And there's no way that you can consume this million set of movies. So they go through many different mechanisms for allowing you to navigate through it anyway, right? They would do it by category, right? They try to identify movies that that are based on your preferences, or they might give it a genre, right? And then many of those, but even then, it's way too many, right? You still might have hundreds of these records. So oftentimes you need to be able to consume that data in chunks, right? Where I show you 10 movies, and then you click on a next, right? And then I show you 10 more movies, right? And then you click on next, right? And then I show you 10 next movies, right? So databases need to support this mechanisms of being able to paginate, right? To create these pages where you can say, well, I want my page contains 10 elements, and then I just want to consume them, page 1, page 2, page 3, and so on and so forth, right? So databases support this through various types of syntax, right? One of the common ones is the keyword top, right? So the keyword top, like the name suggests, it allows you to retrieve the topmost number of rows, right? So give me the, you have a list of records, right? And you say, well, give me the first number of records, first 2, first 3, first 10, first 1,000, right? Or a percentage. You can say, well, give me half of them, or give me only 10% of the entire set of records. Okay. So for instance, in this one, you can either say, top and then a specific number, right? Or you can give it by percentage, right? Now, obviously, if this is so big, then percentages might be still too big, right? So number might make more sense, right? And you can look at the first top most at the top of the list, or the bottom most, right? Now this is not the top number, as in if you look at all the records, it's the one, or there are the records that meet your SQL criteria, right? So if you search all the movies within a particular genre, and that filters from million filters to just 1,000, then this top would be the top of the resulting 1,000, not the 1,000,000. Okay, so it would be the top of, if you say table name where, right, you'll probably have a where clause, where dot dot dot. Okay, so it'll be the top of the records that you've identified, not of the entire table. Okay, so for instance, this select top from persons, right? This would return from persons, since it doesn't have a where clause, it will return all the persons, right? And then you get, well, give me the first two of this from with no where clause. Now this would be the same thing if it's percentage, because the half of 4 is still 2, so both of them return the same set of records. Okay. Now in addition to the keyword top, right, MySQL also provides a keyword called limit. Okay, and limit allows you to say, well, I'll give the query, right? And again, it's very similar to top, right? And but with the difference that limit allows you to also give an offset, which we'll see in a minute, right? It allows you to say, jump or skip over so many records, and then start from there how many you might want, right? Which we'll see in a minute. But by default, limit all by itself, right? All by itself behaves just like top. You say in MySQL, right? So limit number, and you can put it at the end of the select statement. So you first identify which records. So this might come back with hundreds of records, and then you might say, well, no, I want the first 5, right, of whatever came back. Plus you can combine it with ordering, right? You can order by the movie by date, by rating, by whatever, right? Now Oracle has something similar, right? Unfortunately, Oracle does not have limit, but it has something similar called row num. Okay, and row num behaves in a similar way, but not quite. Okay, what happens is that row num is a field that is added, right? When you do a select statement and you query the records, the row num is added as an additional field to whatever the select statement comes back with, right? And so you get the first row is given the number 1, and then the second row is given number 2 and 3, and so on and so forth. Let's see, was a question. Does negative number mean it goes the other way? Oh wow, I've never used negative number. Maybe we should try it. The so row num, when you do a select statement, right, and once you come out of the select statement and you identify the where clause, and it says, okay, well, these are the records that come back, these are the records that meet the criteria, right? After that, the Oracle, what we'll do is that it'll calculate the row nums, right? So the first row that comes back is number 1, then 2, and then 3. So it happens after the where clause. Okay, so for instance, if you say here 10, okay, well, at the beginning, no records have a row num calculated, right? So they all meet the criteria of row num, right? They all meet the criteria of row num being less than some number. Okay, and so once, so meaning all the rows meet this criteria. So it goes in and starts calculating, the first one is 1, second, 2, 3, 4, and so on and so forth, right? And so if you set 5, that means that, if your criteria might have been 1,000, you only really get the first 5, right? So it works like limit, in that sense. It works just like limit. Okay. Now the problem is, right, if you go the other way around, and you say row num greater than 1, right? This one indeed is not going to return anything, right? Because again, in the where clause at the beginning, no records have any number, any row num, right? And so no records comes back saying that the row num is greater than any number, right? So when you're trying to, when the records come back, none of them meet this criteria of being greater than 1. So the row nums don't get calculated. You don't get row num 1, 2, 3, 4, and nothing like that, right? So it doesn't allow you to basically skip, right? And say, well, I want to skip the first 10, right? And then I want to go on beyond that. Okay, let's see. Was there something on the chat? Limit takes 1 or 2 numeric arguments, which must both be non-negative. Okay, great. Thank you. Yeah, we'll see the other example where it takes 2 integers. Right now we just took 1, and we'll see in a minute why you can pass 2 values, which is basically, I'm giving you the hint, right? The first one allows you to skip so many records, right? And then how many you want after that, right? Meaning I want to start at page 10, right? And then after that, I want 10 items after that, right? So limit, those 2 arguments for limit allow you to do that, but not row num. See, that row num doesn't allow you to skip. It doesn't allow you to skip like that. So what I'd like to be able to do is something like this, right? In chunks, right? Where we want to be able to say, well, give me only the records that are within a particular set, right? Between a value of 1 and 5, right? Which this works just fine in Oracle, right? Because you have a limit, right? You know that has to be below a particular value. That means that it allows you to calculate 1, 2, 3, 4, 5 until you get to the number of values, right? And then you can compute whether they are in between a particular between a particular range. So this works fine, except that it doesn't work with order by, right? Meaning if you want to sort the data, right? It works fine in MySQL and SQL Server, but it doesn't work in row num, because, right, the reason is that the row numbers are calculated after the where clause, right, but before the order by, right? So if you use row num, there all the numbers in those row nums are screwed up, right? So for instance, here's an example, right, of retrieving all the records for the employees whose last name is Smith. So after this is done, after this computation in the where clause is done, it identifies all the records and it numbers them 1, 2, 3, 4, 5 all the way to 10. Okay, but this is done right after the where clause. If you add order, right, or say well, before we get to order, say you want row num between 1 and 5, right? So that means that it's only giving you the first 5 here. This works just fine. This works just fine, right? But if you add order, right, and you say order by location, okay, what you get is that the number here, of filtering comes up with the numbers first, right? It calculates the row num first, right? And then when you order by location, notice that the row num are all misaligned. They're all misaligned. Okay. What you would have expected here is that after you order by, these row nums would be recalculated 1, 2, 3, 4, 5, and so on and so forth. Okay, but because they're not recalculated, right, now you can't say like a limit, give me the first 3, right? Because in the first 3, you would get these first 3. But but here, because you don't have limit, you have row num, you would get what? You would get this one, number 1 over here. Number 2, I don't know where it ended up, right? And number 3 ended up in somewhere else, right? It would not be it would not stick to the ordering of a particular location, right? So because it doesn't recalculate the row nums after the order, right? All the value in the row num is really useless to us, right? Right. So somehow we need to force the recalculation of row num, right, to make sure that this value accurately represents the order of this location. Okay. So yeah. So now if you put the row num over here, right, you get values that are all throughout, spread out over multiple places in the record, right? Disregarding completely the fact that we wanted to order it in a particular order by location. Okay, so there's a couple of hacks to get around this limitation, and they're all based on forcing an outer select statement so that the row number is again recalculated, right? So that we can use it to get the between to work correctly, right? So basically the inner query does the filtering of by Smith or whatever identifying the records that you actually want. You order it, okay? Then what you do is that you wrap it inside of an outer select statement, which forces row num to be recalculated, okay? Because it happens after the where clause, right? So you get now a new set of row num, right? So the first one selects the items and the records that you want in the order that you want them. The outer one recalculates the row num, forces the row num to recalculate 1 through whatever in the order of the location. And then now that we have a correct representation of row num, right? Now that we have the correct representation of row num, we can then outside do the between, right? Because now the betweens and the values are correct, 1 through whatever, right? In the order by location, right? So this is, so 3 select statements, 3 nested select statements, right? To achieve what you can achieve with MySQL just limit, right? Limit, right, allows you to do exactly the same thing, right? It allows you to choose a between, right? This is kind of like in between. We want to skip over, right, X number of records, right? So I want to start at record 20, right? And then how many more records do I want, right? So skip the first 5 and then go on to and give me 10 more, right? Unfortunately, Oracle doesn't have, well, actually, maybe in the latest version of Oracle, you have this. But for the longest time, right? So it was so much more complicated to do this in Oracle. Okay. All right. Any questions? All right. Excellent. All right. Let's move on. All right, so let's move on to better pastures. Let's talk about stored procedures. All right, awesome. This is going to be very exciting. Let's talk about stored procedures. All right, so up to this point, we've been interacting. Let's see a question in the chat. Could you unlock the files on Canvas? Oh, they're locked? I didn't know. Let me see. Link, anyone on the internet with this link can view. It says that anybody can view it. Oh, you mean the week? Okay, I'm sorry. Let's see. Right, it was unlocked. Edit. Unlock it. There we go. All right. Thank you. All right, so up to this point, right, we've been using SQL, right, as a kind of like a high-level language, right, that basically the original intent of SQL was to give non-programmers, right, folks that didn't know about programming languages and didn't know, their career was not in software engineering, gave them a level of interactivity with the database that drew on some English-like uh, declarative language, right? Where you could declare, right? Select so and so records that meet this criteria from this data source, right? And it tried to make use as much as possible on simple English grammatical constructs, right? That could be translated and compiled into actual actionable procedures, right? In some programming plan that could be executed, right? And let's see, is a question in the, can someone share the URL link? Oh, you don't have, I did unlock it, so you should have access to that. Let me see. Share, copy the link. I'm going to paste it here in the chat. All right, let me know if you can access that. All right, yeah, so uh, definitely SQL allowed us to lower the bar of entry into being able to interact with these very powerful relational databases, right? But nevertheless, right, SQL is just like English, right? It could be misinterpreted. It's not perfect, and it has a lot of limitations that lack all the things that you could do if you actually had a programming language, right? Where programming language are, have very well defined types of constructs that allow us to interact with data structures, right? We have the concept of data structures, of variables, of being able to call a function, being able to have loops that you can iterate, right? You can have branching, if statements and case statements and switch, right? You can have abstraction where you can have functions that call other functions, and that you can automate scripts, right? So you can wrap around things that are fairly complex into a reusable module, a reusable component that you can then build on something very sophisticated, right? And so SQL all by itself didn't have all these kinds of things that, the most that you could have as in a reusable component was the view, right? Where you can name a query, and then just run that query by the name, right? By the name of the view, right? That was kind of like the closest thing to creating modules or reusable components, reusable scripts. Okay, but it still falls short of having a full-blown programming language, right? And where you can apply many of the software engineering principles, right, that allow us to be much more productive. Well, it so happens that SQL also has these capabilities, right? SQL defines an entire set of programming constructs that allow you to create full-blown programming applications, right? Applications that you can then execute, right, using things such as looping, right, branching, functions, and all sorts of things. Obviously geared towards the use inside of a database. Okay, so store procedures. Store procedures allows us to encapsulate things that we find repetitive, right? You might find yourself that, right, to get your database all set up, you need to insert a couple of records over there, you need to delete over there, you have to update a whole bunch of things. Ooh, wouldn't it be nice to loop through a bunch of pieces of data and then automatically insert all these records, right? Well, you can grab all those all those operations that you have to repeatedly do, right? That there are might be 10 different things that you need to do, insert here, update there, blah, 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 blah. Well, you can wrap this whole thing inside of a function, right? And then you can call that function and you can parameterize that function, right? You can pass in parameters, and then those parameters, you can use them inside of your scripts, right? And so this really opens up an entire new set of possibilities of the types of things that you could do, right? Where now you have a full-blown programming language, okay? Now there's there's a lot of pros, right? You have full-blown access to a programming language. You have abstraction where you can do wrap very complex scripts into a name of a function or procedure that you can invoke later, right? Also these scripts are running inside of the database, right? So it's not like I can execute this from outside the database where it might be insecure, right? That you would have to have access, a login access to the database to be able to execute any of these functions, any of these procedures, right? Also, because it's running right inside of the database, right? It doesn't have many of the shortcomings of running Java or C# or anything that might be running outside of the database, which would have to have network connectivity to talk to the database, establish a connection, send the commands, right? Those are pretty slow. Whereas here you're running right inside of the database, right? So you have direct, immediate access to that data. Right? So it's it's by far the fastest performing. If you're going to access data and manipulate the data, you can't get closer, right, than a store procedure or function running right inside a database, right? Now, even though it's a pro, right, that you are running inside a database, it's also a con, right? Because oftentimes these databases are, they have to be performing a lot of queries for a lot of folks that are remotely connecting and retrieving data, right? Adding procedures and store procedures and functions just adds more burden on the machine that is running your database. Okay, so it's a pro and a con. You have to be careful, right? Obviously, it's also another set of tools that you need to learn, right? It's a completely different language, right? It's yet another language that you need to learn, yet another set of source code that you need to maintain, right? That needs to be debugged, that needs to be QA'd, right? Also, many of the constructs, programming constructs that are that you use are very specific to the vendor, right? Each vendor, because they compete amongst each other, there might be certain features that you can do in one programming language in Oracle that has no equivalent in MySQL or SQL Server, right? So the more you rely on features and store procedures that are only available in certain vendors, the more it becomes that you are tied to that specific vendor, right? So if you want to pick up your database and move it over to some from Oracle, move it over to MySQL or SQL Server or Postgres or whatever, right? It'll make it that much harder, right? That to rip your entire database and just move on, right? So it definitely makes it much harder to migrate outside of that specific vendor, right? Now there's three types of things that can be executed in a database, right? Those are triggers, functions, and procedures, right? I know the presentation is called store procedures, right? But this kind of it's like an umbrella term for things that can be executed. Okay, the simplest of one are functions, right? Functions, like any function, right? You can create a function, you can pass it parameters. It runs some kind of logic, and then it spits out some value, right? It comes back, it returns some value. Now, functions, it depends, depending on whether it's a function, a procedure, or trigger, right? There's certain places where you can use one, but not the other. There's certain things that some of them do all the time, but not the other. So functions, for instance, they never modify data, okay? As opposed to a procedure. A procedure, for instance, can do an insert, can do an update, right? Can do a delete, not a function. A function cannot modify any data in the database, right? Instead, they are meant for returning, doing some algorithm, some computation. They can retrieve data. They can do a select statement, right, and retrieve data and do some computation on that data, right, and then give you a result. Okay, so they return data, right, and now when can they be used? Typically, they can be used as part of some SQL statement, right? So you could use it in the select part, in the where part, right? If you're calculating, the salary for the department, right? You can that query can go out and you give it maybe the name of the department, and that function can then retrieve all the employees, right? Iterate over them and add up all the salaries, and then come back with a single number. Now that number could be part of a where clause, right? It says, give me the departments where the salary is greater than $1 million, right? The salary for an entire department, right? And so you can pass the name of the department, right? And it'll come back with the value of the salary for the entire department, right? That could be in the where clause, or it could be in the select clause as well, right? It could be something that you can pass an argument to it, and then comes back with a single value, which you can then compare against other attributes in the selects or in the where clause. Make sense? Right. So these are the simplest of types of things that you can execute in a database, right? The other ones are procedures. So procedures are somewhat the most versatile, right? They can change data, meaning they could do updates, they can do deletes, right? They can do inserts. Obviously, you can do selects. They all can do selects, right? They can all read data, right? So they can all do a select statement. They'll do looping, and they can do if statements, and they can do all sorts of things, right? But functions don't change any data, whereas procedures, they can change data, right? So for instance, if I can say, maybe I need to test my database, and I want to make sure that it can work with thousands and thousands of users, but I don't have that many users. I'm just getting started, right? It's just a startup, and I barely have 100 users, right? But how do I modify? How can I test whether this works with thousands of millions of users? How do I create all these records? That's fine. I create a stored procedure, right? That has a loop that can generate random users, right? And it can just loop, and I can tell it how many users I want. I said, create for me 1,000 random users, right? And then the store procedure can just loop and then do 1,000 inserts, right? With whatever parameters that I pass it, right? With users that have really long names, short names, that are very old, very young, that have a particular uh, demographics or whatever, right? I can configure that, and then I can do all sorts of inserts, right? I can do a lot of updates, and so I can say, give everybody a 10% raise, right? For those that had a sales bigger than whatever, right? In the store procedure, and it will find all those users, will iterate over them and update all their salaries. So I can create a program, right, to do whatever I want with any of these records. Okay. Returns data. Well, it depends. It might not need to return any data, but you can if you want. But it might not have to, right? If I tell it go and give it a 10% raise to everybody, well, it'll go and do it. It doesn't have to come back. It could. I could ask it to return something and execute it. Usually they're executed from the command line, right? At the command line, you say you call, right, run this procedure, and it goes off and it does its thing. Okay. Meaning they're not meant to be used inside of a select statement or where clause or some bigger SQL query, right? They're meant to be executed from the command line. And then you have triggers. So triggers, they just like store procedures, they can change data, right? So they can do updates, deletes, inserts, obviously select statements, obviously, right? They're not meant to return any data, right? They're meant to be executed. They're meant to be executed when something happens, right? When an event occurs, right? That's why they're triggers. Something happens that triggers the execution of these executable functions, right? And usually what triggers these triggers is the interaction with some table, right? So for instance, let's see, what I think there's a question on the chat. Why is there so much difference much difference in vendors for SQL, but not from languages like Java or Python. So the reason, most of the reason is because these vendors are trying to compete amongst each other. Okay, and, they'll try to lure you in with features that well, they'll provide the standard features, obviously, that are part of the standard SQL language, but they will also sell, try to upsell you certain features that are not available in their competitors, right? And they'll try to convince you that that hey, if instead of writing 10 lines of code using standard SQL, you can just write 2 lines of code and it does the same thing and it performs much faster. And obviously, they're trying to keep you for longer as a customer. Whereas Java, right? There's only one owner of Java, right? And Oracle owns Java, and you don't have many vendors of Java, right? So they're the only sole owners of the standard of what happens to that language. Now, Java almost tried to happen. Same thing when Microsoft, tried to come up with their own version of Java, and trying to compete in this space. JavaScript, same thing happened with JavaScript. Even though there was an owner of the JavaScript language, it started happening that there was a browser war, right? And each vendor was trying to lure you into developing in their particular browser, right? And folks were and so there was a a huge segmentation of the language across multiple browsers. So it was terrible. Something similar is happening in the SQL space, where you have a lot of standard stuff, but they'll offer things that go well beyond the standard, and they'll try to lure you and convince you to use something that is standard, that is particular to them. I hope that answered your question. So triggers. Triggers are meant for listening for events. Like, for instance, you might say, hey, if somebody inserts into this table, right, I want this to execute, right? Or if somebody tries to update or somebody tries to delete something from this table, and that's considered an event, right? I want this function to execute, right? And so once you attach a trigger to these events on particular tables, the trigger can receive information about what it is that you're trying to do. And it says, oh, I see you're trying to insert this record, right? And the trigger can decide, right, can analyze the data that you're trying to insert, right? And it might try to decide whether that data is okay. It could validate that data before actually inserting it into the database, right? It could massage the data and then letting it go through, or it might decide to abort and say, no, I might do some really, really powerful validation, right? That, like, for instance, in the, before someone was asking, how can we make sure that, that certain subrecords, right, in the multi-table inheritance example, right? How can we make sure that I don't insert a record that references the same foreign key or the same primary key? Well, you could put a trigger in there that can do an insert. That on insert, they can run the trigger and check. Okay, what is the primary key that you gave me? Wait a minute, that primary key is already being used over there. I'm not going to let it go through, right? So triggers can audit, right? Can look at your inserts, your updates, your deletes, and either let them go through or abort them, or it can modify them, it can tweak them around and say, well, instead of this, why don't you try that, right? So triggers can do that. Okay, so very, very powerful. All right, so let's take a look at the first one. Let's look at functions, right? So a function is created by using the create function command. You can say create function, and then the function name with optional parameters, right? And then you can specify the body of the function, right? You can then put inside the body of the function. Now it's very common that that before you create the function, it's very common that you put the drop above the create function, so that if you had a function before, it just drops it, right? So that if it gets redefined, you can redefine it again. Okay, now inside of the create statement, inside of the function body, you're going to have SQL statements in there. Usually they're going to be select statements where you are retrieving data. Remember, in a create statement, you cannot do an insert, or you can't do an update, you can't do a delete. You can do a select statement. You can read data from the database, but you cannot modify data, right? Not from within a function, right? So when you have these select statements, you don't want the select statements to execute right away, okay? You don't want to execute them immediately. What you're doing is that you want to postpone the select statements to execute later, right? You want this to execute when you run the function, right? So oftentimes, what we need to do, right, is to modify the meaning of the semicolon, right? Because the semicolon typically means, here's a select statement, or update or delete, whatever, right? And that's the end of select statements, and I want to execute the select statement. Usually that's the default meaning of the semicolon, right? Is that I'm at the end of the query, right? Execute it, right? But because here we are trying to delegate or postpone the execution, right? Usually, especially if you're doing this at the command line, right? When you're doing it inside of Workbench, you're not really using the command line at all, right? You're not typing one line at a time. You're just editing. It's a whole editor that you're moving the cursor all around. There's more keen, more relevant if you're using the command line interface, right? To say, hey, this is the semicolon. Don't interpret the semicolon as in execute this right now. So that's why there's usually, right, again, if you're at the command line, you change the interpretation of the delimiter, and you say, don't use semicolon. Don't interpret the semicolon as the execute the command. Instead, use some other bogus delimiter, which I'm not going to use right now, like // or @ or $, whatever, right? Some bogus key combination, right? So that which I don't intend to use at all, right? I'm just telling you not to interpret semicolon as execute this right now. Right? So I overwrite the delimiter and say, hey, use // or @ or whatever, right? And then at the end, I bring it back the meaning of the semicolon, the delimiter, right? So anyway, so let's try and do a couple of really simple functions just to give you an idea. To create a function in Workbench is really easy. If you notice under the database that we've been using, right? There's tables, store procedures, blah blah blah. There's also functions, right? Here, if you right click, you can create a function. So let's bring up the Workbench. Okay, so in here, I believe I might have created already a couple functions. Let me blow these away. Drop. Okay, and I think I had a couple of store procedures. All right, we'll blow them away later on. I'll say to create a store procedure, a function, you can just right click and say create function, right? And this opens up an editor for you, right? With some bogus name for a function, new function. By default, it returns an integer, but you can change that. You can say it returns a varchar or whatever you want. And here, this one just returns a 1. Okay, so it doesn't do much, right? So let's start with this one. Let's see what this does. Right, so I'm going to apply, and so this is going to convert. This is going to convert this simple the main code is going to convert it into command lines, right? As if we were typing it at the command line, right? So if I click on apply, notice that it's going to do what we would type at the command line if we were interacting directly with SQL, right? First, it selects the database. It drops the database in case it's already created. Delimiter. Wait a minute, this is not doing anything. Delimiter, blah 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 blah. Delimiter. Wait, what? It's not doing anything. Well, let's give it a name. Let's do something. Let's add 2 plus 2. 2 and 2. Okay, add 2 and 2. And we're going to return 2 plus 2. Okay, let's do that. And let's apply. All right, there we go. Okay, so again, it drops the function just in case it exists already, and it recreates it. This is useful for altering the function later on, right? So if we change it in any way, right, we can rewrite it, and then it just blows it away just if it's already there, and then it recreates it brand new. Right? So it says the delimiter. This is what we would type if we were talking to SQL at the command line, which we're not. Right? Changes the $, and the reason is because notice that we have these semicolon here. You have and typically the interpretation when you're typing this at the command line is that semicolon means do this right now, which we're doing it here, right? The semicolon means do this right now, right? This drop is executed right now, drop it right away. But we don't want that to happen when we get to this return. We don't want this semicolon to be interpreted as in, I want you to do this right now. So that's why we have this $. We change the delimiter to $, so that this semicolon is not interpreted as in do this right now. Okay. So again, we're saying use DB design. Notice that here we're not using semicolon. See that? Why are we not using semicolon? Because I just said that the delimiter is not semicolon like it used to be normally. It's semicolon, meaning I want this to execute right now. Use this database, right? I create this function, return blah 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 blah. This is the end of the declaration of the function. Notice the delimiter, meaning this is the end. Do this right now, right? Declare the function is the end of this function, and then we put the delimiter back to what it was before, semicolon. Everybody good? And it runs it. Okay. All right. Great. So now, if we refresh, notice that we have the function declared in there, add 2 and 2. Now that we have it, we should be able to use this function. All right, let's go back and take a look at it. Here it is. We're adding 2 and 2, right? And it creates this this code over here. So how do we actually use it? Right. So as I mentioned earlier, right, functions are meant to be used inside a select statement or where clause, right? In where it evaluates to some value, and then we can compare it. We can do whatever. Okay. So let's use it. Let's use it. Let's open up a new SQL screen and see what we can do. You know, we can say select, and then we can call that function. We can say add to, okay, this is the default, 2 and 2. We can call that like that, right? And this is going to execute, right? This is going to return the value, and it's going to return a result set, right, with whatever value that evaluates to. So we can run that, and there it is. See that? There it uses the name of the function as the name of the column, although we can change that as, and we can change 2 plus 2, and there it is, 2 plus 2, and we have the 4 as the value. Everybody okay? Right? We can use it also as in a where clause, right? I don't know. Do we have any data here? Any interesting data? Users. Okay, we have users. Okay, we have Bob here. Okay, which is the value is 2. Actually, no, we have something that's equal to 4, right? So I could say here, right? Select star from users, right? Where the ID is equal to add 2 and 2. Okay, so this should return just one user. There it is, Elon. See that? Because the ID is 4. So whatever this evaluates to, I can use it in the where clause. That makes sense? Plus, I can pass arguments to this. I could pass arguments, and so this value could be whatever, right? It could go out and retrieve data and do all sorts of aggregations and group by and all that. A fairly complex algorithm. I could have here a fairly complex algorithm that returns a single value. Okay, and that value I can then use it in a query like this. That makes sense? All right. Let's see. We can also take arguments. Like for instance, instead of adding 2 and 2, I can take arguments. And to do that, we can add this this parameter list right? So let's do that. Let's do that, right? So in the functions, we can say create another function, and we're going to call this add A and B. Okay, and we can take as arguments the A, which is an integer. I can take B as an integer, and I'm going to return A plus B. Okay, so if I save that and I apply, there it is, right? It does all the $ stuff, right? And it brings it back to semicolon. We'll say apply. So it creates a function, and I can then use it in the select statement, right? I can say, I can copy this, and instead I can say add A and B, and I can pass it 1 and 3. So that comes back to 4, right? And so that should give me the same Elon, or 2 and 3, right? That's 5, and that comes back as 5, Charlie Brown. Okay, that makes sense. Obviously, we're doing some really dummy stuff, right? Some really simple throwaway garbage. Not that you would actually do this, right? But you could do all sorts of select statements here, right? And those select statements evaluate some data that I can then use in my algorithm. Okay. So yeah, so here's the example of using these values as in the select statements. You can also return varchar, right? So instead of returning integers or floats or whatnot, you can return varchar, right? Okay, so that's functions. So again, functions are meant to be used as part of select statements, where clauses. Now, store procedures are not meant to be used in select statements. Instead, they are meant to be executed from the command line, right? Again, parameterized, and they're meant to iterate and do all sorts of modifications to data, insert new data, right? So, for instance, we'll see an example here, right? Let's create a procedure, and to create a procedure, you do very much like functions, but in the store procedure section, right? So here I had created several procedures, and you can say store procedure, create a new store procedure, and there it is, right? Creates a new store procedure, and then you can put here whatever commands you want, right? So here you might say, select star from users, okay, and that's it. And then it says this would be get all users, okay, and then you can run this. I can say apply, and then you can execute this from the command line, right? As you can say here, you can say, well, I want to call or execute this. You can say call get, what was it called? Get all users. So get all users, right? And I can run that, and it runs the query you would normally run, right? And there it is, all the users. Or you can have another one that says, get me a particular user, right? And this might be, get user by ID. And then you can pass in an integer for the ID. Or this might be user ID, right? Which is an integer. And here you would have, you would have select star from users where ID is equal to user ID. Okay, and then you can apply that. Okay, and then you can run it from here, and you can say, get users or user by ID, and you can pass in the user number 5. Right, and then you can run it, and it comes back as Charlie. Make sense? So basically, it allows you to create all sorts of procedures that encapsulate algorithms that might be useful to you, that you want to run over and over. You know, this instead of this select, it could be create a new user, right? Create 10 users, right? And you give them some parameter as part of the argument, right? And it can then iterate over them and create all sorts of things, or update or delete, right? Let's see, and use them as functions or procedures. Okay. So here it is, right? You create the procedure, you say apply, and then you can call those procedures, right? Here, for instance, are retrieving you select all the graduation students that graduated after the year 2000, for instance, right? Or here we're retrieving the salary for a particular, or all the employees that have a particular salary, right? So give me all the employees that have a salary more than 3,000. Let's see, there's a question on the chat. Are you allowed to do higher order functions, for example, passing functions as arguments into another? No, you can't. No, it has to be a primary data type, a primitive data type. You can't pass functions, not like JavaScript, right? That you can do those kinds of things. Calling a store procedure, we use the keyword call and then the procedure, and then you can pass it arguments, right? That's on MySQL mostly, right? And where our SQL Server, you use the keyword exec or execute, right? But other than that, it's pretty much the same thing. Also, if it has no arguments, you can leave out the parentheses in Microsoft SQL Server. If you want to modify a procedure or function, usually you can say alter, right? And its thing to do is that it drop the old procedure, right, and just redefine it again, right? That's the easiest and most common way of doing it. Okay, so for instance, you would say alter, right, and then you would replace the body of that procedure, or just use drop and re-execute it and redefine it. Okay, so for instance, if you want to alter a procedure, right, what it does is that it creates this drop, right, that will recreate it and redefine it for you. Okay. All right, I'm going to leave it here. Right, we'll come back and play some more with store procedures and triggers next week. If you could read the slides for this week and come back next week, having read all the material, that will definitely help out, and so we can move ahead. All right, folks. Thank you.
Thank you.
Thank you.
Take care.